Yeah, we are live now. Mm, Ladies and gentlemen, good evening and welcome to another talk from Chennai Java community. Today, please join me in welcoming our esteemed speaker for our session. We are thrilled to have Yadu Krishnan with us, a dedicated Scala developer at RiskIdent. With a robust background in Java, Edu was captivated by Scala's power and expressiveness. It led him to become a passionate about, developer for Scala language, and he also became advocate for it. Edu's journey with Scala has been marked by a commitment to learning and sharing knowledge. He authors a beginner-friendly blog on Scala and um, and and he sorry there is he authors a beginners friendly blog on Scala and oversees Baeldung's Scala tutorial Git repository. This demonstrates his dedication to helping others and embarking on their Scala journey. Today's session it is mostly designed for Java developers. Yadu will introduce us to Scala using a new tool called Scala-CLI. He will guide us through Scala's syntax, core concepts, and its seamless integration with the JVM. By the end of the session, you will have a solid understanding of Scala's core concepts and be well acquainted with the Scala CLI, providing you with a strong foundation for further explore on Scala, and you can explore how it benefits your project. Please give him a warm welcome. During the talk, if you have any questions, please feel free to leave them in the comments. I will take them to speaker. Uh, Edu, stage is yours.
Yeah, thanks, Chaitanya. Hi, everyone. Thanks for joining. Yeah, if he has already given some introduction about me. My name is Yadu. I work in a Scala. I work as a Scala developer in a company called as RiskIdent in Hamburg in Germany. So yeah, I'm currently in Germany and Hamburg, and I'm joining this meetup from there. So I work in this company RiskIdent, where as a Scala developer, and I have this, like you mentioned, this is the blog which I have. So if somebody is interested to get to, basics of Scala, you can probably try that and see how it. Yeah, if you can always check with me about what it is, and if you have questions, you can always pick me directly in LinkedIn or Twitter or through the blog. And also, I'm a author at Baeldung, so I take care of the Scala tutorial repository at Baeldung, and also I write for the Baeldung for Scala, Kotlin, Java, and SQL subsites. So I'm interested in learning new technologies and libraries and languages and everything. So that's it about me. So uh, yeah, let's go to the agenda for today. So I know, yeah, it's a Friday evening, so I will try to split this into two parts because it might be a bit longer session. So I would like to do it as a two parts rather than a single one. So in this is not the um, agenda for this today's talk alone, but this is the whole agenda with two separate talks together. So depending on the time, I will stop at probably the basics of Scala, and then we can go into advanced concepts in one of the next talks if there are interest. So I will take you through the basics of the Scala language. So how about the complete basics, with some syntax, some history of Scala, and some usages. And yeah, I will take you through some of the features, the main features of Scala language using this new tool called Scala-CLI. So it's probably a year or 1.5 years old tool, but it has completely captured the Scala ecosystem, and many people are using it. It has made learning Scala very easy. So I will uh, take you through this. There are multiple usages of it, but in this session, probably I'll take the most basics of it, and probably in the next session, we'll come to the more advanced features of the Scala CLI tool, which can be even used as a build tool for for a smaller project. So we'll see those additional details probably in the next session. And also we'll try to build a Scala application. Yeah, maybe once we learn the basics, we can start using this Scala things we learned to build a Scala application using this. So yeah, like you mentioned, if you have any questions in between, please send a message in the chat. So yeah, let's start with the basics of Scala language. So just to give some history and information about the Scala language, it is designed by the author called Martin Odersky. So he created the language at the EPFL University in Switzerland. So initially it was more of um, like learning or research language, but it became a, mainstream language once it became popular, and the power of this became known to the community. It's a statically typed language, so it's similar to Kotlin and Java. It is static typing. However, it even has more strict checks than Java and even Kotlin. Um, it supports object-oriented programming with functional programming. So it is, yeah, it's mostly on JVM, right? So when we always compare with Java and Kotlin, but when you compare with Java and Kotlin, this supports much more functional programming paradigms than Java and Kotlin supports. Yeah, so however, you can still write completely very uh, normal object-oriented programming as well with the Scala language. So that's why um, Scala became very popular, or yeah, it got this popularity because of this combination of object-oriented programming with the functional programming. So Scala supports multiple platforms. So yeah, as we all know, since it's a majorly JVM based language, you can use it on the JVM. And there is there's a version called as Scala JS, which is a JavaScript target where you can write the code in Scala, um, like yeah, just like normal Scala application, and you can compile it on a to a JavaScript, and you can use it. So this is very nice to build application in a single language rather than using multiple languages. So if you are comfortable with Scala, you can do JavaScript coding, JavaScript like coding, um, and generate the JavaScript file out of it. So there are multiple libraries which is supporting currently with the Scala JS, so you can do a lot of things with it. Yeah, there's another target called a Scala native, which is an LLVM target. So you can write Scala code and and convert it into LLVM target, so that you can have native applications, just like yeah, which can actually bind to C libraries and use it on native platforms. So this can make use of the LLVM interoperability, and can be used in wherever the LLVM based applications can be used. And it also, the good thing about it is it doesn't have the JVM in between, so it's much faster, and you can actually start up the application very fast. So when it comes to command line applications, this is one of the very best approach to use Scala native. So in this talk, I'll be mostly focusing on Scala 3. So uh, to give a background about it, Scala has the Scala had multiple versions, and each one were previously were called as Scala version 2 with minor versions 2.11, 2.12, 2.13, 2.14, something like that. Even though these were minor versions, they were not source compatible. So if you write one code in Scala 2.12, it might not compile in Scala 2.13. So it was like that. But a few years ago, a new version of Scala was released called as Scala 3, which rewrote the Scala compiler completely, and it was started from scratch. So it is like a new language itself with huge changes from the Scala 2, with a lot of polishing on the Scala 2 language, and improving the Scala 2 language. So for this talk, I'll be mostly focusing on the Scala 3 based syntaxes. However, some of the syntax works in Scala 2 and Scala 3, except for the some concepts such as macros and things which is very advanced, which we don't have to worry about. So yeah, this is how a Scala compiler or Scala application, Scala file looks like. So we have a you can write the Scala code in a file and with the extension as .scala. So in this case, we have hello.scala. So you can compile this file using Scala-C compiler. So Scala-C hello.scala will compile this source code, and this create an intermediary format called as tasty. So hello.tasty. So the hello.scala will be converted into hello.tasty, and this will be again converted into hello.class when it is applied on the JVM. So this tasty is an intermediary format which is used to support multiple like support forward compatibility and backward compatibility. So from Scala version 3 onwards, this tasty file will be the one which is read by the compiler. So you can write Scala 3.0 file and it will convert to tasty, and Scala 3.1 or 3.3 or any other future versions can read it. So it doesn't directly link depend on the class file, which is a Java, yeah, which is used in Java as well. Instead, it uses tasty file, which has additional um, what do you call additional information for this compiler to work. So like I mentioned, Scala compiler is a very heavy compiler, and it actually does a lot of transformation on the code before it converts into the class file. So at the end, we the Scala file, what the Scala code what you write would convert into a class file, and some of the features which is directly needed in the Scala will not be available from the class file when your DC is back. So in such cases, what happens is this intermediate format is that can help the Scala compiler to understand more about it and perform optimization. So this is how it actually looks like. But you don't have to worry about what format and other things which is completely internal to the compiler. So yeah, let's write first Scala program. But before going into the Scala program, um, so like I mentioned, there is a tool called a Scala-CLI. So you can use this Scala-CLI to set up your local environment. So I can share the link to the Scala-CLI in the chat. So if somebody yeah is interested to install it right away, you can do it. Um, I'm not sure if everybody can see this comment or some Chaitanya.
Link, Edu, I will share that in the YouTube comments. You shared it in private chat.
Okay, sure. Yeah. So, and yeah, while we're going, I just want to know how many people are, I mean, how many people joined here are already knowing Scala, or are there people who like, I mean, yeah, or are there people who knows Scala, or this is completely for the first time you're working with Scala, so that I can just yeah evaluate how I proceed.
Yeah, guys, if please drop your answers in the chat. We will know how if you are new to Scala or you already used it.
Okay, so while we wait for it, so we can, I hope the the link is posted for the
Yeah,
Scala CLI.
link is posted.
Okay, so we can you can actually go to this link and download this Scala CLI tool. It's really cool, and you can just you only need this particular tool to work with Scala for now. So you don't have normally you have to work with a lot of uh, yeah, normally you have to work with you have to set up a lot of things previously to work with Scala, but with this new Scala CLI tool, it's very easy. So you don't have to worry about JVM, JDK, and anything when you work with Scala CLI tool. So that is the cool thing about it. You don't have to have any version installed. You don't you it doesn't matter whether you have a JVM or JDK already installed or not. But yeah, you can um,
Edu,
use
we
it.
got some comments.
Okay,
You
yeah,
can
I
see
saw that.
them.
Okay.
iPad.
Good to know somebody is there who reads my blog.
Yeah,
Um,
the second one is
yes. Yeah,
Um,
is there is dependencies JVM version depending on the Scala version? Uh, no, actually there is nothing. So Java, you can use. I think generally one Java 8 is what is suggested, but it doesn't matter which version because most of the things in Scala has its own standard library, and it uses mostly the Java 8 based thing. So you can use Java 8 plus anything with Scala, so it doesn't matter.
we have one more user. He said he never worked on Scala before.
Okay.
It's nice now. He's going. We are going to learn Scala. Yeah.
Okay, so yeah, so like I mentioned, this Scala-CLI tool is once you install it, you can directly, you don't have to set up anything apart from using this. So yeah, you can just set it up, and once you install, you can actually run the command scala-cli, which would actually run or start a REPL. So read, evaluate, print loop, which is like a command shell script or a shell command, where actually you can write the Scala code. So I can present first just to show what it looks like. Yeah, let me just share the screen.
Yeah. Screen
Okay, so
is
this
added
is,
to the stage.
yeah, thanks. So this is the terminal I'm using, and if you can just do scala-cli, so this will start up the Scala REPL, and you can see the information about the Scala REPL here. So it is using Scala version 3.4.2, and this is the JDK version 11.0.9.1. So right now it is using this particular version.
Edu,
Uh,
sorry to interrupt you.
yeah.
Can you please change the font size? Can you increase it? It's
Okay.
not
Sure.
so
Yeah.
much clear.
Okay. Is it better now or
Yeah, it's better.
okay? Yeah. So this is the JDK version, and this is the Scala version, and you can write code here directly, and it will execute immediately. So let's get started with the basic thing. So you can yeah, so this is one of it, the Scala CLI. This is command line, and I'll go to the next part after showing one basic part of it. So you can write any statement here, any valid Scala statement here. So for example, in Java we have the system.out.println, but Scala you can just use a println, um, which is, yeah, the last part is enough. So you can just do this statement like this, and it actually prints the content to the console. Similarly, if you want to, let's say a normal variable, like if you want to define a string, so what we can do is we have this keyword called as val. So val name equals Yadu. So what this does is it creates a variable called name, and it, yeah, so here I'm not defined any type. So it's not like a string name equal to Yadu, how you do in Java. It actually identify the type based on the value it assigned to it. So in this case, you can see this how the Scala compare evaluated it. It evaluated it into a string variable, and yeah, as in this variable name. So this now name contains a value Yadu. So I can again just, yeah, it just evaluate this statement again and again. So if when I do type this name here, it just evaluated and printed or showed this value to the console right now. So forget about it. So the main thing about is unlike Java, Scala is promoting immutability. So by default, when you use most of things, it will be immutable. That means that you are not allowed to change the variable once it is created. So the keyword val to define a variable is it will define an immutable variable. So right now we have created this name, and i- if it was in Java, you could just do name equal to something else. But here in Scala, it's not possible. So you can see this when you try to reassign a predefined, pre-declared variable to something else using val, it actually shows error that reassignment to val. So this is not allowed. So you cannot once you create a variable val with with val as the keyword, you cannot reassign anything to it. So as a result, like what Scala is promoting is to have immutability so that you are not accidentally changing any variable. So in Java you can probably set one value in one place and you can override it something else, even if you are not actually intending to do that. So here it is completely opposite, and it's ask you not to do that by default. Yeah, if you want to create a mutable variable, it is possible. So instead of val, you can use this keyword called var. So if you use var and name, so it created the it created a variable name again. Since it's a REPL, it doesn't matter the duplicate name, and I can still reuse the same variable again and again because it overrides content. So that's also it's not actually a in Scala you cannot evaluate, sorry, reinitialize the same variable in different statements, but here it is since it is just a REPL, it is possible. So that's all. So I created this var name and I can execute the same statement something else before. Now if you do this print line with name, which is already there, you can see it's actually printed name, which is something. So it is able to override this variable with the new value. So this is how you actually define mutable and immutable variables. Like I wanted to show about the types, about the type inference. So you have this val um, name which I saw before, and anything what you give here, it the Scala compiler will identify that it's a string data, so it automatically assign the type as string. So you don't have to specifically provide this. I think this is now available in the Java I don't know 21 or before with var keyword. So you can actually use something similar in Java with the but only inside a function. But here it can be used anywhere. So if you create a variable with id equal to 100, sorry, I equal to 100, it put the type as integer and created this variable. So you don't have, it will automatically do this. So if you want to create a long variable, you can do 100l, and now it actually created long instead of integer, because by default it uses integer, and if you want to use long, you have to do with l. Similarly, you can do a boolean val be equal to true, and it will create a boolean variable. So it's all the data types what we have in Java and Kotlin, they are all there, all the primitives, but there are no primitives here. Everything is an object internally. But the whatever primitives equivalent things are available in in Scala. So you can use all these variables directly. So this is mainly about the basic syntax, and we have seen val and var to create an immutable and mutable variable. Um, you can use a keyword called def to define a function. So like fun keyword in Kotlin, it is same as that. Or you can define a method here or a function here, and let's say prints. We can do something else. Hello, and I can write a statement here, which is just so you can see this def hello equal to print line hello here. Here it is defined with the unit. So the unit here it's like equivalent to void in Java. So this the statement what we do here, this print line is a equivalent to void. Like it prints the statement content to the console, and it doesn't return any value. So as a result, it's like the type in Java would be void, and in Scala this statement is actually a type of called unit. So as a result, when this evaluates here and the compiler identified this is a function which is of type unit. So it actually found this. Now if you rewrite this function a little bit, um, let's say with 100, you can see this function's type changed to integer. So it calculated this. So this is how you define a variable, and you can sorry, define a function. So you can define another function with um, parameter. So right now I created initial one without a parameter. So I can define a function with parameter. This is the syntax for creating a function with parameter. So name colon the type. So here I can do here, and it's not the suggested format, but I would still do this right now. So here I created a function where it will do hello comma that name what you did. So I can do this hello and pass in a string variable to this function. So it printed this hello comma Yadu to the console. Now let me go back to one function again with the without any argument. So um, I would just say hello here, which is a function which always returns hello. So yeah, I think yeah, this is the right. Now you can how is it different from writing this val hello equal to hello? So when you look at this, both look same. Here it's a def hello string and val hello string. So the difference is that we using a def we create a function, but using a val you create a variable. So uh, that means that when you have a val, it's a variable, and it will be initialized only once. So when you access or when you create the variable for first time, it would set this value hello to this variable, and that's it. Whenever you do the call again and again, this just return the same value which is there in the in this one. It will not evaluate it again and again. However, you if you create a function like this, and every time it evaluates the same yeah, on every call it evaluates. So that is the difference between using a def and a val for defining a parameterless function. So it is like always it creates always it recalculates the value. So if, here you don't see anything because we are seeing the same hard coded string every time. So I guess you could do something like so. Yeah, let me clean this and start one thing. So assume that I have defined a hello with system.current time in millis. So and now when you print this, so here when I do this, it actually evaluates. Each time you can see this is changing. So on 3 invocation, it is changed because each time it is evaluated on every call. So if you make this a val, you can see the difference. Oh, sorry. And I'm actually calling this again and again. So you can see notice that on all the 3 times it is exactly the same value. So it actually initializes for the first time, and after that it will not do anything. It just returns the value. So that's one thing. There is also another keyword called as lazy, which is applicable on variable. So you can do a lazy val name equal to something. So this works the same as val, but the difference between val and lazy val is that val will initialize um, a- mm, as soon as it is defined. So when you have first, like as soon as the application is initialized, it will initialize these values. But lazy val will evaluate only for the first, only when the first access is done. So this is very good for delaying some operation which is expensive. For example, if you have some variable which needs to calculate based on some complex logic, and it is not necessarily used all the time, you can make it lazy so that it would be evaluated only on demand. So if that particular variable is never accessed, that means that it will be never allocated and it will never be executed, and yeah, the whole process of executing and calculating will not be done at all, so until it is used. So this way you can delay the execution until you actually need it, but once it is initialized, it will never be recalculated. So then it works as a val. So only difference between lazy val and val is that one is initialized immediately and other is initialized only at the end whenever it is used for the first time. Whereas def is initialized or def is evaluated every time on all the calls. So yeah, which is, so that's the reason you can define a def as a function or as a variable, like similar to a variable where you want to recalculate every time, which looks like a variable but actually it is a function. So this is some of the very basics thing about defining a variable function and and this some of the common keywords in Scala. So now I will exit from the this terminal and I would like to show something about the VS Code. So right now we have the Scala CLI installed. So we actually use this command line um, actually yeah, to use this Scala term applications. So right now what I will do is I will use a VS Code and it uses the same Scala CLI terminal, so Scala CLI tool to execute it. So let me share again. Okay, I hope you can see the yeah, the Scala file in VS Code. So what actually happens is with the Scala CLI, like I mentioned, you can actually do a lot of things like an IDE. So for doing that, what I would like to do is you have, let's say you have a um, Scala file which we created before. You can like it any using any text editor, you can open it and assume that, let's say you have a um, file called as I'll just for um, testing purpose I can show you something. Let's say I'll create a file using this test.scala, right? And in terminal I just created this a function called as def main or whatever I've seen I showed you here. Once you do that, you can actually, so yeah, once you have this particular file called as test.scala, or in this case I've created a jug.scala. It can be an empty file. What you can do is you can run the command scala-cli setup IDE dot. So it's a bit complicated command for the first time users, uh, but once you once you do this, let me try to join. I think I'm trying to post this link or the command to the YouTube chat.
Please post in the chat. I will take it to the YouTube comments.
Yeah, so this is the command which I posted in private chat. So this is
Yeah.
the command which is used to set up an ID. So Scala CLI actually can create a IDE like the tools, the meta files which is needed for an IDE to work. So there is something called as metals, which is under the hood. It is it's a build tool which is used by Scala CLI, and it set up the necessary things which is needed for Scala CLI to work as an editor, as a IDE. So this will set up this will run the on the directory where you have the Scala file. You can run the Scala CLI setup dash IDE dot, and it would create the necessary files, and then you can actually open the directory in VS Code if you have VS Code, or IntelliJ IDEA also supports this. So whichever way, you can actually open this in any of the editors, and any of the editor which is supported by metals. Right now I guess VS Code, there is IntelliJ, there is Vim, NeoVim, and also there is some I forgot, there's one more tool which is supporting this. But yeah, VS Code is probably more popular. We can use it to use it. So once you do this, you would get a similar environment which you are seeing in the screen. So it creates a file, and then you can there would be a tab called, you have to install this plugin called as Metals. Once you install this plugin, you can actually get some import bill. So you forget about it. Maybe I think once you import it, you'll be able to get these things, and you can start install this plugin and then start using it. So if you have this plugin called as Metals, it would actually show this run. There's a dialog here. You can see this run and debug. Once it compiles, you can click on it and run it. But it is not necessary to do this for this tutorial. So if you have anything, you can directly run it on the command line, which I'll be using right now. So
Could you please increase the font again?
oh, sorry. Yeah, sure.
Yeah.
It's better, I
Thank
guess.
you.
Okay, so this is the first application, where first small application which we can go and write. So where you can create a file called as whatever the name dot Scala, and you can write this statement def hello print line, print line something, welcome to Scala, and you can use this annotation called as @main. So this is annotation which is coming from only from Scala 3. So prior to Scala 3, this was not there. We had to write something called as extends app and then do it, but yeah, it's not needed anymore. So you can just add this annotation @main, and uh, that means that this function what you're going to write now below this, that function automatically becomes the main entry point. So it is like writing a public static void main. So it's exactly like that. But yeah, you would be able to directly run this application right now. So if you have this small code, you can actually run Scala-CLI, Scala-CLI, and the file name. So in this case, it's called jug. Java user group jug.scala. So you can see this detail about it. This is compiling the project with this version Scala 3.4.2 and JVM 11 in my case, because I'm in my environment it is Java 11. Probably it would use Java 17 or something else which you have. So you can see this, it's printed this content to the console. So this is this is the easiest way to get started with writing the first code in Scala. Okay, so let me. I guess I should switch to slides. I guess.
Yeah, I will change. Sorry.
So I'll come back to the code once this. So these are the some of the highlights of Scala. So Scala is very concise when you compare it with Java. It's much less verbose. So you don't need to use so many things, like you don't need to have any semicolons. So you can just write without any semicolons. You don't need brackets. So the even the parent the even the brackets for curly brackets are optional. If you want, you can still do it. But with Scala 3 onwards, it's completely optional. You don't have to have anything. You can just, like Python, how do you write in Python? You have this indentation format. You can use the same indentation format in Scala as well to write code. So there are no getters and setters needed. So when you have a Pojo classes in Java, we have to write like, or records, like similar to records, there are things like case classes in Scala, where you don't need to write any getters and setters, which is now it's possible in records. Uh, there is no return keyword necessary. So what it happens is, in Scala, if you have a function and you have a last statement within the function, will be automatically the return value. So if you write a function def hello and equal to just name as string, right? So that there's only single statement in that function. So the last statement is the defining of the word means defining of the string. So as a result, that will become the return type of this function, and the last statement will be automatically returned from out of the function. So you don't have to have any return statements from it. Yeah, it is possible to do early return using return keyword, but it's not generally suggested to do that in Scala. So it would be always it's normally suggested to use the normal approach. If you have early returns, you'll normally try to make it an if condition or do something else with that. Scala has a very a strong type inference, so it can actually infer the types very clearly. We already saw that with the integer, long, and string. And there are even more advanced things if you write more advanced code. Like if you have, there is something called as union types. So if you have if you have something called as, let's say, val or something like val name equal to Yadu and like a pipe symbol, or um, yeah, something like, if you let, you can actually create a type called as string or um, int. So that means this function, whatever it takes, it can actually return one of these two values. So there is, this inferences can also be done by the Scala compiler. Scala is completely interoperable with Java libraries and JVM libraries. So we can use any Java library in Scala. So it makes much easier to use already well established Java libraries in Scala. It has a very powerful type system with the types, like with this type which is not normally possible in Java, called as union types, intersection types, type classes, and there are something concepts called as currying and so many things, which is functional programming concepts. Um, yeah, like I mentioned, it's immutability is what is preferred in Scala. We have something called as case classes, which is similar to data classes in Kotlin, or records in Java, and pattern matching, which is there in Kotlin. However, Scala's pattern matching is one of the most powerful pattern matching in, yeah, definitely in the JVM ecosystem, which is the most powerful pattern matching. And even in compared to other languages, it has one of the best pattern matching logic involved. So it is like switch statement in Java, but it's much more powerful. You can do a lot of things with this pattern matching. Um, it has a very powerful standard collections library. So you have a lot of functions available on the collections, like list, set, and yeah, map, and whatever it is. And it has much more methods than it's available in Java, and much concise methods. There are no nulls in Java generally, in Scala generally. So you're normally you avoid nulls. However, since it's on JVM and on Java, so it can have null, but it's generally not preferred to use null in the in Scala code. Instead of that, it promotes the usage of types called as try, either, and option. So option, which is equivalent to the optional keyword in Java, or the question mark in Kotlin. Either is like it's a data type which can hold one of the two values. So if you have some situation where a method which throws an exception, right? Like for example, if you have if you in Java, when let's say when you have a function which does something and it can throw exception, you use the checked exception to tell about it. Instead of that, you can define these values as a type itself in Scala. So you can use either type, and you can tell that this particular method, let's say if you're reading a file and converting it, like you're reading a file as a string and returning it, you can create a type called as either string, comma, um, IO exceptions, because you're reading a file, there's a possibility of IO exception happening. Now you can tell this from the data type, the return type. So you can be very clear that this particular um, method returns two values probably. One is for success case, one is for the failure case. So on success, it returns yeah, it's normally like either of left comma right. In the left side is normally called as a bad case, and the right side calls the right case. So you write either of IO exception comma string. That means that this on successful execution, this function returns a string variable, string value, and on failure it actually returns an IO exception. So this is using the either type. And there's a type called try, which is like that, which is a type for handling exception. So we have try catch in Java, where it doesn't actually tell on the type level that this method throws an exception. But this in Java, in Scala, you can use the type as try, and that means that this particular um, function or the variable could fail at runtime. So it could fail because it is returning it try. So it has two values. It is either success or failed. So depending on the so you are forced to handle this in your code. So you not actually miss out using yeah, you not miss out handling an exception case when you have these types. So you are actually forced to do this handling by yourself using this try. So we probably, again, I can show you this examples in the later slides. There is a very powerful concept called as implicits or givens, which makes which is very useful to implicitly pass parameters to many of the functions. So if you have, let's say, some parameters, you want to pass it to across all the functions. So you have a logger, and you keep instead of defining it as a global variable, you have let's say 10 methods, and you want to pass this function to 10 methods while you call it. So you can define implicits, and it would automatically pass these variables to this wherever it is defined to these methods without even explicitly passing it. So yeah, it's one of the very powerful feature of Scala. It's called implicit in Scala 2, and which is renamed to givens in Scala 3. So yeah, I'll be using both sometimes. So, um, and there is something called as extension methods, which is also available in Kotlin, where you can extend an already existing class and add more functions to it. So if you have a string function, string class, you cannot add any new methods to string and use it, right? So because it's not handled on our side, it's from the JVM, or yeah, it's from the Java. So if you want to enrich the string function with some additional methods, like a, let's say, um, to camel case, which is probably not available on the string, what you can do is you can use these extension functions and create this function, and then wherever string is used, you can use this additional extension functions wherever it is needed. So Scala supports a lot of functional programming concepts like higher order functions, currying, and yeah, and type classes, which I mentioned. So all these are supported in Scala, which probably a bit on the higher level right now. Maybe I'll not go into this concept right away. Um, so these are some of the very popular Scala-based uh, applications or libraries. So Akka is like a actor model, which is built on Scala. It also has a Java binding or Java library for it. So this is probably one of the uh, it was one of the most popular library quite some time ago, but now it has gone less popular with, so yeah, there are some other licensing changes and something happened. However, this was the reason for me getting into Scala. So that, yeah, I actually worked on Java before, and yeah, I was working in Java with Akka, and then yeah, slowly I learned Scala. Like the company which I worked, we switched to Scala, and then yeah, with that I also learned Scala based on that. There's a framework called as Play framework, which uses Akka internally. It's like a Spring Boot. You can say it's like, yeah, it's something like Spring Boot in Scala, but yeah, it also has the Java version. Spark, you already know, and I guess you don't need any introduction on Spark. So almost all are in Scala, and now there's a Python binding as well. Kafka is the major part of Kafka is also Scala based. So that's why Kafka also has the Scala 2.12, Scala 2.13 dependencies, and there's some compatibility issues with different versions of Scala. Yeah, the Twitter or X.com right now. So that is built. Most of the core code is built in using Scala, and there's this most popular chess engine called as Lichess. So it's also built on Scala. It's one of the biggest Scala project, which uses very high concepts, which is available in Scala and more. So just a few of the common libraries. So this part we already saw some of it. So there are no primitives, everything is object. Yeah, int, long, double, string, character, boolean, all these are the types which we already have. So yeah, we discussed val versus lazy val, def versus, yeah, var, and all these things. So the one of the main thing about Scala is functions are also first class citizens in Scala. So that means like you can use functions just like any other types in Scala. So you can define a function and you can pass the function to other functions. So like you're passing a variable to a method, you can pass another function to a method. So similarly, you can return a function from a method. So it's all it's like just like a variable, so you can use everywhere in the Scala code. So that's what's make it more powerful, and yeah, where you can do a lot of things using these functions. Yeah, in Scala, everything is an expression. So like I was telling before, uh, last statement of a function returns, I mean, automatically become the return statement. Similarly, uh, if you can write an expression and assign to a variable. So if you look at this code here, if condition a plus b, else a minus b. So it is an if else conditional, if else expression. So this can be assigned to a variable, unlike in Java. So if condition, if some condition true, then it does a plus b, else it does a minus b. So based on this condition, it assigns the value and it will become val result. So here the results type probably because if a and b are integers, so this will become type integer itself. If a and b are string by any chance, uh, then this also will become a string. If a and b is a some other class which has defined method plus and minus, you can it will become that type. So uh, again, the thing is here, everything is an expression, and like I mentioned, you can even have like you can even have methods in classes with operator overloading. Like you can do plus, unlike I think in, I'm not sure if, yeah, in Java we can't do that, right? So we can have plus, and you can actually create classes with the function plus, and then you can use it. So it could, that's the reason I said this a and b could be an object, it could be an integer, it could be a float, it could be a string or anything. So the type inference, so you can see here, from here itself, based on the condition, based on the boolean, based on a plus b or a and b, the type of this variable is yeah, inferred. So I'll show you some of the cases in the code. So the other things are, there is class object trait. So I think you would easily get the difference as when you compare it with the Java. So class is class in Java, same as in Java. Object are like singleton classes. So you don't have to actually create instances by yourself. If you define it as an object, it will create a singleton object, and there will be only one instance available in the entire system. So you can safely do that, and Scala will ensure that there's only one instance of this object available in the JVM at that time. Trait is similar to interface, but it's more powerful than interface. It has more in Scala 3, that in traits itself can take parameters, so which is not possible in interface. Just like a class, it can have parameters. Yeah, we'll see these things in one of those future class yeah, future sessions. So yeah, we'll speak about the collection library next. So like I mentioned, the Scala has a very powerful collection library. So you can define collections of list, set, map, and all these types in Scala. So you can do something like list, like here you can see this val numbers equal to list of 1 2 3 4 5. So that, as easy as that, you can create a list with this syntax. So it creates a list of 5 elements, and the variable numbers will automatically become list of list of integer, because each numbers are integer in this. And the list or the collection library provides a lot of inbuilt functions. So you can do numbers dot sum. It will sum up all the elements of this list, and yeah, and it's yeah, make it become 15 in this case. You can do the same thing on set. So you can create a set using set of 1 comma 2 comma 3 comma 4, yeah, to 5, and you can do set dot sum. Similarly, you can actually create a map. So it's like hash map, but however, I didn't mention the syntax here. It is using something called as an key. Yeah, it's a key value pair where you can define using arrow. So key is yeah, key arrow value. So if one arrow Yadu, it means like it creates a map of key of integer and value as a string. So this way you can actually create maps. Uh, so there is this. Yeah, let me just see. Okay, so okay, I lost this animation here. It should have been below this. Yeah. So these are some of the collection classes which is available in Scala: array, list, set, map, tuple, range, and more. So Um, Array is same as something similar to list, but with the array properties. Here, what I would like to mention is something called as tuple, so which is not available in Java. I'm not sure if it's available in Scala, I mean, in Kotlin also, but yeah, it's a tuple. It's like a unnamed case class. Like you can actually define tuples are like just a collection of any type. So you can create a tuple using this parenthesis, and maybe I'll show you the code later. This is very useful data type. And there is a range data type, which is in Kotlin, you have two double dots and you can create a range. In Scala, you can use this range class to create a range, or using the function called as to. So we'll see this as well. So the best thing about this Scala collection library is that you can use the unified methods on all the collections. You have map, flat map, filter, find, and all the functional programming methods are available on the Scala collections, and you can use them on all the time. We can, whether it's on list of string, or a set of something, or maybe set of or list of our classes. You can still do all these operations on them. So it's much easier to do this operation. So if you look at the below part, you can see this numbers dot map. So map is I guess I don't have to explain map, because probably you would know what map in Java. So it's same as that, but iterate through each element of this list and multiply by 2. So here you can see this numbers dot map underscore multiply by 2. It will double the values. Similarly,
Edu, sorry to interrupt you. Unfortunately, we do not have much time left with it.
yeah.
Uh,
Okay, I'll just run a bit faster on this. So these are few of the functions available here, like map, filter. You can do take the first two elements, and for each will apply something like a map, but a bit different. Yeah, you can apply pattern matching, like I mentioned. It's very powerful. So you have, let's say, a name, right? So here I have an option of string called as you can have something called as sum or none. So sum means a value exists in an option, and none means value does not exist. So I've defined a option here with variable as name, and you can do this match statement on it. So it is like this is a pattern match, and you can do name match, and the conditions are case statements. So case sum of n and none. So sum of n means, like, if this option has a value, the value will get extracted into the variable n. So you can just print line welcome to n, and it would actually extract the value n directly and assign it to the variable n. And the good thing about this is that, if let's say if you've forgotten about one statement here, like case sum you gave, but you didn't have this case none, the Scala compiler will give a warning that this name can have multiple situations. You are not handled all the cases within the code. So this is very good to um, to avoid accidental mistakes. Similarly, you can do the match statement, like which is like I said, it's a there are a lot of possibilities with the pattern matching. So if it's on a number, let's say here val number 97, so you can do this case n, and you can apply the conditions on it. So case n, if n mod 2 equal to 0. So if it is a number, and if it is an even number, you just print even. If it is case n, and if it is an divisible by 3, you can do n mod 3 equal to 0, and it will do this. Case n means it will match anything. So sorry, it matches anything, and it would go to the third state if it is anything not which is not a multiple of 2 or 3. The same thing you can apply on a case class. So here I didn't go to the syntax of case class. This is how you can define a case class, which is similar to records, case class, person, and the fields of the case class. So here I defined a person, and I can assign a person just like this. You don't need a new keyword for doing it. You can just do val person equal to person of Alice and 25. So it creates this instance of person immediately. And you can actually do this pattern matching on that as well. It doesn't matter. It need not be a symbol, string, or a number. It can be applied on a case class. And you can see it's how powerful it is. case, person, and you can do this Alice and 25. Right? So it would exactly match this statement only if the first, like the name is exactly Alice and the age is 25. In if this person had the same instance, only then this first statement would be matched. If it is something else, let's say here you can do partial match. So case, person, Bob, and age. So here it what is this? If the person instance has the name Bob, and no matter what is the age, this would be matched here. And you can Bob is, and you can extract the value age from it. Similarly, on anything else, like so here you are extracting any other thing, so which is not Alice or Bob, it would extract into this variable. So here you can say println, yeah, this is the name and this is the age. This, yeah, this is very powerful, and it's yeah, it can work on multiple types, and it has this destructuring support on case classes, and also you can do a lot of uh, operation on it. You can even do regular expression matching on it, which is very powerful. So I would like to quickly switch to code and just show some sample. Yeah, if you have time. So
We can have a quick example.
just I will
Um,
go through the some of the code here just to show. So this is what some of the data types which we saw before. So here you have this Scala util.try, which I defined to create a try. So before that, I'll show you what option is, which is equivalent to optional. You can create option of something with the option bracket, or you can create a none using option dot empty of a type string, or you can do something called as val empty2 colon option of, you define option of something, um, and just equal to none. So this is also equal. These both statements here, 6 and 7 line, both are equivalent. In one place we are defining the type explicitly here. In other case we are defining on the value side. So this is how you can define an option. So this is function called as find, which we saw in the collections. So what it does is this find will return an option of something. So if you have a list and you do find of something, let's say if I have a list of 1 comma 2 comma 3 comma 4 comma 5, and if I do list dot find underscore greater than 1, so this underscore means it's a kind of a placeholder. You don't have to define a variable. So it's a shortcut for writing something like, like this is the actual syntax, but normally you write some variable value and an arrow here, and then you can use this value as a lambda, like how you in Java. Instead of single arrow, it's a single equal, like, yeah, dash. Here we use arrow, but this is yeah, this way you actually the how you define a lambda. But you can make it even shorter, because you don't need to do more on that. Only one time you're using this particular variable, so you can do just underscore. So this underscore would automatically take each value of this list, and it apply this condition greater than 1. So it returns the first value which is matching this condition, because we are using a find. So in this case it returns option of 2, and had this been 10, which we don't have any values, when you're trying to find value which is greater than 10, here it would return a none, because there is no value which is greater than 10 in our list. So similarly, we can use try here. So try is something I told, like, exception thrown. So if you do try something and do 100 divides, this should throw an exception of divisible by 0. This might fail it. So this has a type called as, you can see here, try of int. The Scala compiler automatically inferred the type. And so from here you're sure that that, okay, this could fail. So this would wrap the exception in case if it happens. So it will not throw exception directly. Now you can apply the pattern matching on it, or you can do, yeah, you can print the value. Similarly, you can do either, which I said before. So there's either of string comma int, which has a value called as right or left. So you can define a right of 100 or a left of something for failure cases. And then you can do map on it. Yeah, a left dot map on it and something like that. So here there's a pattern matching which example which I showed in the slide, but I would like to show one very quick string. So if you have a variable uh, which is very, let's say, very super nice something. So if you have something called as some random string which you normally use it in any string manipulation things. Let's say hello um blah, something else, right? So you have something like this here, and you might have some code where you have to actually extract this code within a within some brackets. So you normally write a regular expression to do this particular thing, so which is not so nice, or which is become make it complicated. So what actually you can do is we can even use pattern matching on these things to extract these values. So if you do code match, and you can so you can do something like this is called interpolator s, where yeah you can combine the string. So um so abc, sorry, so there is, you can define a variable here which is, let's say, awesome nine. So I can do something like, okay, this is, let's say, prefix, and oh, keyboard is not working. Extract something, and let's say something, right? So here you can do something like this. So I can just define any variable case, and it doesn't matter, like keyword, the name doesn't matter. So I'm just wrapping it as something. So it didn't match, and I would just give this any here, right? So let me run this one here. Okay, sorry, right now this is not, yeah, I don't have any because here it's 97 and nothing is, there's no condition for me here, so that's why this is thrown a pattern matching exception. See, you can see this one here, extracted equal to blah. So you actually, you can very easily do something here. So now this can actually extract values into prefix, extract something. So if you want some pattern is that you want to do something on it, it's very easy to do this with the pattern matching. So this is very easy. Like when I do analysis on some logs, what I always do is I use this simple string read and just give the pattern like this and extract it. So it's much easier than thinking about a very complicated regular expression to filter these values, extract these values, and do it. So this has become one of my go to do a lot of string operations using this pattern matching. So this very powerful to do these operations in Scala.
Edu, we passed the time. Shall we
Yes,
give some time to user questions?
yeah, sure. So now we can stop it here, and we can go to the questions.
Yeah. Um, guys, thank you for being with us. If you have any questions, please feel free to post them in the chat. Edu will answer them. I will take them to Edu. Meanwhile, other users post the question. I have a question.
Okay.
So, yeah, it's about lazy variables that you explained during the basics.
Yeah.
uh, when actually these lazy variables get initialized, when you actually place it like lazy name equal to something you placed it, so will
Yes,
it
yes.
be initialized then itself?
No, so the lazy variables are they are initialized only on the first usage of this particular variable. So if you have this, let's say, a function which is let's say if you have a conditional statement on let's on Windows environment, let's say if you have something like somebody you're detecting the operating system, and if syst OS equal to Windows, do something else, do something like that. So if you think that on this particular case you have maybe you have some variable which instead of adding it inside the if else condition, you let's you define outside this function. What happens is it will be executed all the time, or yeah, whenever it is used. If you're keeping them as a lazy val inside this block, or yeah, it doesn't matter where it is. So if you keep them as a lazy val, so only if this particular where the line of this definition is reached, only in that case this lazy val would be initialized. So if that particular operation is a very expensive operation, when it's about initializing something, which is not always the case, so in that case, you can use them as lazy val. So if only if this particular flow is reached, then only this particular instance is created and executed. So as a result, you would be avoiding it in most of the cases. Only when demand you can do it. So you can push it. You can delay the execution of this one until you use it for the first time.
Okay.
Hope it's clear. Yeah.
Yeah, it's clear. Thank you. There's a question. Is there a dependency to JVM version depending on the Scala version? I believe
No.
there is dependency, right?
Yeah, there is no. There is no dependency for most of I mean, yeah, for all the cases, unless the library you are using is dependent on some version. For example, if we have using a library um, which is depending on virtual threads, which is available only in Java 11, only then you have this problem. Otherwise, for the Scala code, there is no. So there is a library called as aux in Scala, which uses the virtual the JVM 21, the JDK 21 virtual threads. So to use that, you must have Java 21 as the base. So otherwise, there is no dependency on it. So you can use it on most of things, unless there are very rare cases where this could happen. If you use some JDK features which is only available in particular version, then you obviously have the dependency. Otherwise, there's no dependency. You can use most of it.
Clear. It's like Kotlin as well, right? Kotlin also does not have any dependency with
Yeah.
JVM. Uh,
Yes. It's not. Yeah, it uses the JVM, but it's not very tightly coupled with the exact version of the JVM, because
mm,
yeah, Scala or yeah, Kotlin, whatever they actually does wrapper around. Yeah, it's like another like on top of it, JVM. So it uses only the common features, and many of things are yeah not have a direct dependency fully.
mm. And Ravichand is saying hi. Yeah.
Okay. Yeah.
Yeah, one more question I have is like, um, um, uh, you said about the play. It's can you
Framework.
explain? Yeah, play framework. Is it built around Akka? Is
Uh,
how it is
Yes,
different?
yes. So the play framework is it's like you can think of as another version of like something like the Spring Boot. Yeah,
Mm,
something like Spring Boot, but yeah, it's not same. It's a framework which is underneath. It is using the Akka actors. So it's like you can define. So this like similar to the Spring Boot, you can define the routes for this application. Like you can quickly bootstrap an application using the uh, play framework, uh, which actually uses the Akka underneath for all concurrency purposes, and
mm,
the roots and all you can define as configuration files. So it's much many of these roots can be defined, and then you can write functions like how you do it in Spring Boot itself, methods and something like that, and you reduce some of it. So it's more of a by what do you call, like a lot of things are handled by the framework itself. So you don't have to worry about the concurrency a lot. It will be automatically handled by the actor using the Akka. So as
mm,
of recently, there was a licensing change on Akka, and there was a fork was created called Pecco. So now like the play
mm,
framework currently uses the Pico, so it actually uses that and creates the application.
Yeah, we got one more
Okay.
question.
Yeah, I saw that. How
Uh,
do you package Scala project? Is it packaged to a jar? Yeah, yeah. So there are multiple ways we can. One of the approaches, you can create a jar, like how you do it in any Java application. So uh, there is a there are multiple build tools in Scala, which is, yeah, the most popular one is called SBT, and yeah, there are plugins to it where you can build your application. So the most common one is probably jar, yeah, which is easy to do. You can create a jar package application as jar and execute like any other Java application. You can also create the platform version, platform dependent things, like you can create a Debian package, or yeah, Fedora package, or all these things using this native packages, and make it like and deploy it on those servers as it is directly. Or you can even create, like if you're using something like Scala native, which is like, yeah, the native application, we can even create a Scala native applications, and it can run directly using the LLVM ways. So that is also possible. And what are the other ways we could probably, yeah, mostly these are the packaging ways. Yeah, jar and, yeah, the normal applications.
that's nice to hear. Scala is also having native support.
Yes, yes, and and there it can also use we can also build application using the Graal VM image, native image also, like, yeah, the plugins actually use all these things to yeah, any of things can be used for the plugins.
That's nice. So, guys, thank you so much again for staying with us. And I hope you learned something new in this Friday evening. I wish you a nice rest of the day and happy weekend. Uh, Thank you for joining. Uh, if you want to join our mailing list, I have dropped the links in the comments. Please join us to get to know further about future events. Thank you. Bye.
Yeah, thanks everyone for joining. Have a nice weekend.
Bye.
Bye.